Hello everyone, on behalf of our team Touch Zone, in this video I am going to show you how to create a new project in East Coast Studio and what are all the configurations for our East Coast Studio that will require for our project Helix and the hardware configuration. In the next video, we will see the demonstration of our project. Okay, let's move on to our project. Our project title is Embedded Lift Intelligent Execution, which is shortly termed as Helix. So this is our company and these are techniques and their contribution. So this is a block diagram of Helix. It includes 4x4 keypad matrix and it will be connected to Renesas, ARM Cortex M33 based Renesas RA62 and an Arduino Uno for serial monitor display. So let's move on to East Coast Studio configuration. If you are new to the East Coast Studio, then you have to watch this. If you know how to configure East Coast Studio, then you can skip the 10 slides. So when you are opening the East Coast Studio for the first time, you can see a window like this. In this window, please ensure that Renesas RA C or C++ project is selected and click next. And after clicking next, you can see a window like project name. In that you can configure the name as you wanted. Here we are configured as Secure Embed Project and then click next. After that, important window will be popped up. In that video, you can use what the board you are configured. If you are configured BJK, then use BJK. Mostly we are using BJK board. BJK RA62 denotes the beginner level kit, and after choosing the board, device will be shown like R7FA6E2 BB3CFM. They should be checked once. After that, GNU ARM embedded is selected in the tool chains. After that, in that advanced version of 13.3.1 ARM 1324 is selected. Also in the debugger window, you can choose JLink ARM. After clicking next, you can see a window like this. In that window, right now, flat non-transparent project is enough for everyone. And if you want to make a secure project like in the future, you have to configure the trust zone based secure project. After clicking next, you can see a window like this. If you are creating for the first time, then you can choose none. If you want to configure or include something into the existing project, then click the preceding project, and in the preceding project you can type the name as what you are configured before. Then after clicking next, then here we are not at all using autos. So in the autos selection, you can choose no autos, and the build artifact selection, choose executable. After that, a window will pop up. In that window, bare metal minimal will be chosen. Now the overall configuration has been done. So now you can able to see the summary of what you had configured. Okay, now let's move on to the stack configuration in East Coast Studio. In the project, we have configured timer stack, GOT for display, as well as the external interrupts. So first we will see how to configure a stack. So in the same window, you can see the stack-like structure. In that, it is in between the linker section and component that I mentioned here. So in the stack window, click on stack. In that, you can see the new stack. Click on that. In that, many options will come. In that, you will choose connectivity. In that, UART or underscore SCA underscore UART will be selected. After selecting this, you can see a window like you can see a image like G underscore UART not UART. In the bracket, R underscore SCA underscore UART is a stack tab. After that, after double clicking the stack, you can then select the properties. In the properties, you can configure like in the name, you can configure as G underscore UART not. In the channel, configure it as 9, data bits as 8 bits, parity as none, and stop bit as 1 bit. In the interrupts, we are not at all using any function, so make sure the callback as null. And in the receive interrupt priority and the remaining all priority must be maintained as priority 12. And in the receiver transmitter pin, make sure that P10 and P109 is selected. In the baud rate, 9600 selected. The same should be maintained in the Arduino Uno serial interface too. So if you are troubleshooting to find how to find if you are troubling in how to find a stack tab, just do double click the configuration.xml, which is shown in the project explorer file. After that, you can able to see the stack configuration. So that's all about the UART configuration. Let's move on to timer configuration. In the same window, if you are click stack, in that new stack will be pop up. In the new stack, open the timer. The timer central PWM underscore R underscore GPT will be having. In that, if you are click, then you can see a window like G underscore timer underscore 1 millisecond timer in the stack tab. Then in the same way, if you double click it in the properties, you can configure the name as what you are mentioned in the code. Make sure the channel is 1 and mode is periodic, and the period should be 0x0001 and the periodic unit is millisecond. In the interrupts, in the code we are used timer underscore 1 millisecond underscore callback. So in the callback you have to mention the same name as here, and also make sure that overflow or cust interrupt priority should be maintained as priority 2 instead of disabled. Also, we need to configure external interrupt configuration for our 2 columns. Follow the similar step for the stacks to develop here. After you clicking on it, you can see the G underscore external underscore IRQ0 and G underscore external underscore IRQ1. If you double click it, you can see the properties. Here we need to make sure that the channel should be selected 7 and trigger should be falling or rising based on your code, and digital filtering is enabled. And here we are used callback because in the all entry code we are used callback function, and make sure that the pin IRQ7 P408 is configured. The same can be done for the extra interrupt 1 too, but here the pin we have configured is P103. That's all. We have configured the stacks. Now you can see a image like generated project content on right side top of the eSquare Studio. In that, click it, then some icon will be popped up and you can see like this in the project explorer. Then double click the all entry code. This is the all entry code, pseudocode for our project. You can make changes whatever you want, and this is the actual logic in our system. Okay, after configure the all entry code, then we need to build the code. Press Ctrl plus B to build the project, or else click hammer like structure which is present in the left top of the eSquare Studio. Then after that you can see in the console window like build finished, 0 errors and 0 warning. After that, click the debug to run the code, or press F5, or you can see a insert like structure. On pressing that, you can able to debug the code. So that's all about debugging and running the code. So now let's move on to the hardware configuration. The models that we are used are ARM Cortex M33 based RA62, Arduino Uno, and 4x4 keypad matrix. ARM Cortex M33 based RA62 board is mainly executing the Helix elevator control algorithm and state machine logic. Arduino Uno is for serial monitoring and system status display. 4x4 matrix is used for scanning and flow requests. Let's move on to see the configuring keypad matrix. We are configured 4 rows and 2 columns. The 4 rows should be output mode and the columns as input mode. The output mode is configured as state I, initial state I, and in the input mode pull up. And this all the 4 rows and 2 columns are mapped to the corresponding Renesas pins, as mentioned in this. This is the interfacing between keypad and Renesas. Okay, now let's configure the pins in the eSquare Studio. So let's move on to the same stack tab. In that you can see some structure like summary, BSP, clocks, pins, interrupts. Pins is present in between the clocks and interrupts. You can click on the pins. In that choose P008. In that go to mode and make the mode as output mode initialize. Similarly configure for P113, P409 and P500. And move to P408. In that select configure the mode as input mode and pull up or down as input pull up. Similarly configure for P102. Now this is the Arduino Uno and Renesas interfacing. So here that we are Arduino Uno we are used for serial interface monitoring. In that white wire is in the above image you can see the white wire is for ground to ground connection, and black wire indicates transmitter of Renesas to receiver of the Arduino Uno. Also this is the Arduino Uno code that we are used. The final overall interfacing of the diagram is here. First we will press the flow request from the 4x4 keypad. It will be controlled or configured in the Renesas RA62. From where it will be transmitted to the Arduino Uno. From where it will be moved to PC, from where we can able to see the output. These are some of the outputs, and the outputs are cleanly explained in our demonstration project video. In the next video, you can see how actually the lift is moving, how actually the configuration is happening, and how 4x4 matrix is used, how scan algorithm is used. Also, why we are not using 8051 microcontroller for this project, what are the benefits of using RA62 ARM Cortex M33 based, those and all we are discussing in the next video. So that's all about our video. Thank you.